Okay, Algebra 1, this is the last lesson we're going to do in Chapter 7, solving special types of linear systems. So, if you will look in the book with me on page 459. Okay, an inconsistent system, we just had before we had a consistent system and it had one solution. An inconsistent system has no solutions. Okay, a consistent dependent system is a system with many solutions. Systems of linear equations, again, two or more equations with the same variables. And parallel is lines that never cross. And they have the same slope, if you remember that. All right, so let's take a look at these. Show that the linear system has no solution. Now remember, when you graph linear systems, in order for there to be a solution, it's where the two lines cross. So check what happens right here. When we graph these, we find they're parallel. So since they never ever cross, there is no solution, because the solution is the point at which the two lines cross. So parallel systems do have no solution. So you say not possible. Now in graphing, it will show up because they'll show up as parallel lines. If you are doing elimination, this is how it looks. You take the equations and you subtract them, and they don't work out. If you notice, everything cancels out over there with the x's. If you subtracted this, you did minus, this would be a minus, and this would be a minus, and this would be a minus. That would cancel, and you can't solve for anything. Okay? So that would be false, and it would not be possible. So no solutions are parallel lines. Okay? So then consequently, many solutions are systems that have the same equation. So check these out. You graph it, you get ready to graph, and when you make this graph, you find out they're the same line. They run right on top of each other. So it's where they cross. Since they cross at many points, then we say many solutions. Okay? Now, substitution or any of the other methods that we have learned, you will end up, when you solve it, when you eliminate it or you try to do substitution, you won't end up with any variables. Again, the variables will all cancel out, and you'll end up with a true statement like -4 equals -4. So you would say true, so that must be many. Okay, so it says tell whether the linear system has no solution or infinitely many solutions and explain. Okay, so there's a couple of ways. I still do the elimination thing. I look and I go, you know what? These, if we added, would cancel out. These, if we added, would cancel out. So you'd be left with 0 equals 9. So this would be no solution. Okay, so before I can do any canceling, I need to set this up. I need a minus 2x, minus 2x. So I get -2x plus y equals -4, and I'm still where I want to do my, so I'm going to get the 3's opposite of each other, so I'm going to multiply through by a -3, so that's going to be 6x minus 3y equals 12. That cancels, and look, that even cancels. So I end up with 0 equals 0. Well, 0 does equal 0, so I get that it's many. Without solving the linear system, tell whether the linear system has one, no, or infinitely many. Okay? Without solving it. We'll have to graph it then. I suppose, is that what they want us to do? Oh, yeah, look at the slopes. We'll put them in slope-intercept form. And if the slopes are the same, they're parallel. So look at there, the slopes are the same, so then, wait, they have the same slope and the same, oh, they're exactly the same. Look at those. So since they're exactly the same, it would be many. It might be better to just solve for y on these. So we solve for y, slope-intercept form, and then we look at them. Same slopes, that means they're parallel. So this one has no solution. Write and solve a system of linear equations. An artist wants to sell prints of her paintings. She orders a set of prints for each of her 2 paintings. Each set contains regular prints and glossy prints, as shown in the table. Find the cost of 1 glossy print. Okay, so let's say regular is X and glossy is Y. So we're going to have 45X plus 30Y equals 465. 15X plus 10y equals 155. So elimination, let's multiply through by -3 here. So that's going to be -45. That's going to be -30. And 155 times -3 is -465. That cancels out, that cancels out, that cancels out. 0 equals 0. Well, we have, no, so it's many. There's many solutions to this, so there's not enough information. We can't answer this question. And again, it's exactly what we did, multiply through by -3. So we need more information. So without solving these, so let's solve for y on this one. So I'm going to go -15, so I'm going to minus x, so -3y, -x minus 15, divide by -3. 2 negatives make up 1/3 x plus 5. This one, minus 2x minus 2x, -3y equals -2x plus 18. Divide by -3. 2/3 x minus 6. Okay, those are different. So that one, I believe, has one solution. It didn't, nothing, there's no parallel. There are not many, one solution. Okay. What if a glossy print costs $3 more than a regular print? Find the cost of a glossy print. Would you be able to do it then? I don't know where that example is. Let me go back to that example. A regular print costs $3 more than a glossy print, so this one would be, wait, 45 regular, 30 glossy. $3 more than a glossy print. I don't know how they did that. Go back, I don't think there's any work on that one. Let me see. Go back. Well, let me go back to that. Let me get this back up here. Hold on. The glossy print costs $8. I think we'd have to figure out how much all of that would be, then it would work for us. So let's just remember, parallel lines have the same slope. If it's many, you have the exact same equations, and if it's one solution, then you can solve it. All right, so give that a shot. This is it for this chapter. We'll see you.